this episode, we zoom out and look at the full life cycle of an AI system, because a lot of AI risk comes from what people forget exists. Beginners often picture an AI project as a straight line that goes from an idea to a build to a launch, and then it just sits there doing its job. But real systems behave more like living products. They evolve, they get updated, they ingest new data, they attract new users, and they often get reused in ways nobody planned. When you map the life cycle clearly, you make sure there are no blind spots where risk can hide, like forgotten data sources, undocumented changes, or unclear ownership after launch. The point is not to drown in process. The point is to build a simple, consistent picture of what stages exist, what decisions happen in each stage, and what evidence proves you stayed in control. If you can describe the life cycle in plain language, you can also explain why controls must exist before, during, and after deployment. By the end, you should be able to tell the story of an AI system from the first idea all the way to retirement, and you should understand why each stage matters for safety, privacy, security, and trust. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A life cycle map starts with the idea stage, which is where risk is cheapest to reduce because nothing has been built yet. At this stage, the organization is deciding what problem to solve, who the users are, and whether AI is even the right tool. This is also where you define the boundaries that later become guardrails, such as what the system is allowed to do and what it must never do. A common beginner misconception is that risk work starts after you pick a model, but the earliest and most important decisions are often about purpose and scope. If you choose a use case that is high impact, you might require stronger review, stronger testing, and stronger human oversight from the start. If you choose a use case that touches sensitive data, you might limit what data is collected or decide not to use certain data at all. Mapping the life cycle means you explicitly include these early decisions in the story, instead of treating them as informal conversations that leave no trace. When the idea stage is clear, later stages become easier because everyone is working from the same assumptions. After the initial idea comes a feasibility and design stage, where the organization explores what is possible and what the system would look like in practice. This is where you begin to answer practical questions like what data will be needed, what outputs will be produced, how users will interact with it, and what human decisions remain in the loop. In AI, feasibility includes both technical feasibility and risk feasibility, meaning can we build this without violating privacy, creating unsafe outputs, or exposing the organization to unacceptable harm. This is also where you consider whether you are building, buying, or combining vendor services, because vendor choices shape the life cycle in big ways. A life cycle map should show the key design decisions that influence risk, such as whether outputs can trigger actions, whether users can rely on the system for important decisions, and whether the system will be exposed to untrusted inputs. Beginners sometimes focus on model selection as the main design decision, but lifecycle thinking says the bigger design decisions are often about how the model is used. When you map this stage, you also decide what testing and evidence will be required later because you already know what risks you are trying to manage. Next comes data planning and preparation, which deserves its own explicit place in the lifecycle because data choices are where many AI risks are born. At this stage, you determine what data sources will be used, how data will be collected, how it will be cleaned and labeled, and how data quality and lineage will be tracked. You also decide what data should be excluded, which is just as important as what is included, because minimization reduces exposure. Privacy risk is tightly connected here, because data might include personal information or sensitive content that requires strict purpose limits and access controls. Security risk shows up here too, because data pipelines can be attacked, corrupted, or misconfigured, and that can lead to poisoning or leakage. A lifecycle map should make data flows visible so people cannot claim they did not realize a certain dataset was used. Another beginner misconception is that data is fixed, but in many systems, data changes constantly, which means risk can change constantly. When you map the lifecycle, you include how data changes are handled, reviewed, and documented. After data preparation, many AI systems move into training, tuning, or configuration, even if the organization is using a third-party model. This stage is about shaping behavior, whether that means training a model, fine-tuning it, adjusting retrieval behavior, or setting parameters and constraints. The risk angle here is that changes made in this stage can be hard to see later if they are not tracked, and they can introduce unexpected behavior. Reproducibility matters, meaning you should be able to explain what version you used, what data was used, what settings were applied, and why those choices were made. A lifecycle map should show where versioning happens and how you prevent quiet drift, because drift often begins with small changes that feel harmless. Another key point is that tuning and configuration decisions often encode trade-offs, such as balancing helpfulness with safety or balancing personalization with privacy. Beginners sometimes think there is a single best model setting, but in reality, settings reflect priorities and risk tolerance. When you map this stage, you are also mapping the trade-offs that later must be defended and monitored. Testing and validation is a stage that must be explicit in the lifecycle map, because it is where you prove the system behaves within acceptable boundaries before it reaches real users. Validation is not one thing. It includes checking performance, robustness, fairness concerns, and safety concerns in ways that match the actual use case. It also includes checking that the system respects constraints, such as not revealing sensitive information and not providing unsafe recommendations. A lifecycle map should show who owns validation, what evidence must be produced, and what happens when tests fail, because a test that fails without consequences is not a control. Beginners sometimes think testing is only about accuracy, but for risk management, you also care about failure modes like hallucinations, bias, and misuse. Another important element is environment, meaning you test in conditions that resemble real use, including messy inputs and edge cases. When the life cycle includes strong validation, deployment becomes a controlled step rather than a leap of faith. This stage is also where you establish baseline behavior, so you can detect later drift in production. Deployment is the stage many people focus on, but lifecycle mapping makes it clear that deployment is not the end. It is a transition into continuous operation. Deployment includes how the system is released, how access is controlled, how changes are approved, and how rollback is handled if something goes wrong. It also includes how users are informed about limitations, because user expectations are part of risk. For beginners, it helps to think of deployment as a promise, because the moment you deploy, you are promising that the system will behave within certain boundaries, and you will be accountable for that promise. A lifecycle map should show what gates exist before deployment, meaning what must be true before release is allowed. It should also show how monitoring starts immediately, because early signals after launch can reveal issues you did not see in testing. Another key point is that deployment often includes integrations, like connecting the AI system to data sources or workflows, and those integrations can create new risk paths. When you map the lifecycle, you map integrations explicitly, so they are not hidden sources of exposure. Operations and monitoring is the longest stage in many life cycles, and it is where many organizations lose discipline because the exciting part of building is over. In this stage, you watch for drift, misuse, performance degradation, and safety failures, and you also maintain access controls and incident readiness. Monitoring is not only technical metrics. It includes user feedback, complaint patterns, and signals that the system is being used in ways you did not expect. A lifecycle map should show who reviews monitoring, how often, and what actions are taken when issues appear. It should also show how updates are handled, because many systems are updated frequently, and each update can change risk. Beginners sometimes think that once a system is deployed, its risk is stable, but in reality, the environment changes, data changes, and user behavior changes. That is why lifecycle mapping includes processes for ongoing review, not just a one-time approval. If the operation stage is not explicit, blind spots form, such as unreviewed updates or monitoring that exists but is never acted on. Incident handling is another lifecycle stage that should be mapped clearly, because incidents are not rare exceptions. They are expected events in complex systems. An incident could be a privacy leak, unsafe output, unexpected behavior change, or abuse by users or attackers. The lifecycle map should show how incidents are detected, how they are triaged, how containment happens, and how communication is handled. It should also show how evidence is preserved, because learning from incidents requires records of what happened and when. A beginner-friendly concept is that incident response is part of control, not a sign of failure, because the ability to respond quickly reduces harm. The lifecycle map should also include post-incident learning, meaning how root causes are identified and how controls are improved. Without this loop, the organization repeats the same failures. When incidents are mapped as a normal part of the life cycle, people take readiness seriously and do not hide problems out of fear. This creates a healthier risk culture and better outcomes. Life cycle mapping also includes governance checkpoints, meaning moments where cross-functional review confirms the system remains within approved boundaries. These checkpoints might happen before launch, after major updates, after significant changes in use, or after incidents. The goal is to prevent scope creep, where a system gradually expands into riskier territory without deliberate approval. A lifecycle map should show how approvals work, who is accountable, and what evidence is required at each checkpoint. Beginners sometimes think governance is only about rules, but governance is also about visibility and decision rights. If nobody knows who can approve expansion, then expansion happens by accident or by whoever is loudest. Lifecycle mapping helps by making decision points explicit, so that teams do not confuse speed with lack of oversight. It also helps ensure that evidence is produced continuously, so audits and reviews are based on facts rather than memory. When governance is embedded in the life cycle, it becomes part of normal operations instead of a surprise hurdle. Finally, retirement and life cycle closure is a stage that many teams forget to plan for, which is exactly why it becomes a blind spot. Retirement is not just turning something off. It includes deciding what happens to stored data, what happens to logs, what happens to documentation, and what happens to downstream systems that relied on the AI outputs. If the model was trained on sensitive data or used sensitive inputs, retirement may require deletion, archiving, or access restriction in a way that meets privacy and legal obligations. If the system influenced decisions, you may need to preserve certain records for accountability and compliance even after the system is gone. A lifecycle map should show how you remove access, how you prevent orphan integrations, and how you communicate changes to users. Retirement also includes the human side, meaning people need to know the system is no longer reliable or supported, so they do not keep using it informally. For beginners, the main lesson is that retirement is part of risk management, not just an IT cleanup task. When retirement is planned, you avoid leaving behind data and dependencies that can create future harm. As we close, mapping the AI lifecycle clearly is one of the most practical ways to reduce risk because it forces you to acknowledge every stage where decisions are made and where control can be lost. From the first idea, through design, data preparation, training and configuration, testing, deployment, operations, incident handling, governance checkpoints, and retirement, each stage has unique risks and unique evidence needs. Blind spots appear when a stage is treated as informal or when ownership is unclear, and those blind spots are where surprises and harm emerge. A clear lifecycle map creates a shared understanding across teams, which makes coordination easier and makes responsibilities visible. It also makes change manageable, because you can see where updates happen and how they are reviewed. For a brand new learner, the key takeaway is that AI risk management is not one activity done at launch. It is a continuous discipline that follows the system from birth to retirement. When you can tell that lifecycle story without gaps, you are far less likely to be surprised by risk that was hiding just outside your view.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.